everyone, and welcome to Safety Week. I'm Ann Osborne with MSA Safety, and we're really excited to have you here with us today. For all of us at MSA, OSHA's National Safety Stand-On Week gives us an opportunity to bring attention to safety and working at heights. According to recent statistics, 40% of all fatalities in the construction industry are a result of a fall, making them the leading cause of death in construction-related accidents. OSHA's National Safety Stand-Down is a simple and focused way to remind workers and their employers the risks of working at heights and the steps they can take to mitigate those risks so that they can return home safely each and every day. And while this week-long focused effort is a little later than usual this year, and while we can't be joined together at job sites across the country, that doesn't diminish the need to provide you with the education and training you need to stay safe on the job. Today's presentation is a crash course on the basics of fall protection, or the ABCs of fall protection as we like to call it. In this presentation, we'll be covering the various components of a personal fall arrest system and some things you need to consider before putting your personal fall arrest system together. And starting with the letter A, for anchorage points and connectors, I'd like to hand things over to one of our global fall protection training instructors here at MSA Safety, Chris Irwin.
Hello, my name's Chris Irwin, and I have a background in safety. Prior to working in this field, I worked in industry and construction, but now I have 10 years in the field of fall protection. Moving into anchorage points, one of the first things that we would talk about is the strength that's required. So just as a very basic review, we know that the anchorage point that we're going to attach to needs to be able to withstand one of two forces. So 5,000 pounds is what I like to refer to as option A. Basically, the point that I want to attach to needs to be able to support at least a 5,000 pound static load. Something that we commonly use to, as a reference to remember that is think about suspending a full-size truck from the I-beam, for example, that we're attaching to. If we don't go with that first option, the second option is what we call a certified anchorage point. In a case like that, basically, the anchorage point needs to be able to hold at least 2 times the weight that it could see in a fall. So moving on from the actual strength of the anchorage point, we need to talk about how we would actually connect if we were going to work in this location. So one of the first questions that commonly comes up is, say that I've got my harness on and I've gone shopping and I've gotten my fall arrest lanyard. Is it okay for me to take my lanyard and wrap it around the anchorage points and tie it back on itself? And the short answer is no, this is not okay. There are a couple reasons why I'm not allowed to do this. First, the webbing is not designed for this. So in this case, the webbing rubbing up against the I-beam is a big issue. Additionally, the snap hook is also not designed for this type of a connection. So in order to connect to this I-beam, I need to have an additional device, and that'll be what's known as an anchorage connector. So the first option that we have is what's known as a cross-arm strap. Basically what we have is a length of webbing that has D-rings on the end. So in this case, I have a big D-ring, so-called because it looks like a D, as well as a small D-ring. In this particular case, I'll take one end of the strap and wrap it around, passing the small D-ring through the big D-ring. And then I will cinch it tight just like this. Now, before I continue and show you some of the other things that I'll do to finish getting this set, I'll just briefly mention that this is now where I'm going to connect the snap hook of my lanyard. So whereas I could not wrap the lanyard itself around the beam, the strap is specifically designed for this. Now, if we were in a full fall protection course, we would talk about a variety of anchorage connectors and what is okay for proper use and what's not okay. In the case of this strap, what I'd probably want to do is wrap it around again and then take this small D-ring, pass it through the big D-ring a second time, and get it cinched down. Basically, by doing that, I've eliminated all the extra strap, which will reduce some of my free fall if I were to fall from this location. So this is one example of what's called an anchorage connector. We'll look at a second example of one of those. So the next option that I have is what's known as a beam clamp. So in this case, basically what I have is a bar with 2 moving clamps that slide from side to side. So I can push that in, and I likewise can do it with the other side. So the same concept if I want to attach this to either the top or the bottom flange of the I-beam, I would just bring it up here, and I'll slide that in like that. Now, I need to do several checks to make sure it is properly secured, but in this case, again, the idea is I'll connect my lanyard here, and basically that's what allows me to attach to my anchorage point. So with both the beam clamp and the strap that we just looked at, these are the anchorage connectors, and the I-beam is the anchorage point. So the next thing I'd like to talk about is what's known as a horizontal lifeline. This is a bit of a more complex anchorage connector, but it's still an anchorage connector. So as you can see in this particular case, I'm still connecting into a column, which is my anchorage point. I'm going to grab a rope that goes over a wheel on the inside and basically pull it tight. There's a lock underneath. And at that point, what does this give me? I've got the ability to walk horizontally back and forth where maybe I don't have any connection points overhead, but I do have a couple of solid points at either end. So in this case, just like before, I've got my follow rest lanyard, and now I actually have a ring that's given to me specifically for the purpose of connection. So with this, I've got the ability to walk horizontally wherever my line goes. So with that, I'm going to throw it back to Ann. She's going to do the B of the ABCs, which is body wear.
Let's review our body wear. I'm going to use an MSA V-Fit harness, but if you have your own harness in front of you, that's fine too. There are all different types of harnesses with different attachment points for different applications. The body harness is a critical piece of the personal follow rest system and should be inspected before each use and at minimum annually by a competent person. When I inspect my harness before use, I like to follow a pattern. I start at the D-ring and then work my way down. So let's start with the D-ring. What are we inspecting for? Well, we're looking for breaks, cracks, corrosion, pitting, and/or dents. None of these are acceptable. But my D-ring looks good here, so we can move on. Now let's look at load indicators. These are folds in the web. It has a straight stitch, and if it's ripped or open, it would indicate a fall. That's why some people call load indicators tattletales. So you want to ensure that load indicators are intact. For our next step, we look at our labels. All labels must be present and legible. Important information is inside. It will tell you what the weight capacity is of the harness and which standards it meets, like ANSI, OSHA, or CSA. Everything looks legible here, so I am moving on. Now I look at my webbing. You must inspect your webbing for any frays, rips, tears, or holes. The smallest tear, 1/8 of an inch cut, can reduce the strength of your webbing in half, so it is really important that we inspect for this. Next is stitching. You need to look at your stitch patterns. No broken stitches are allowed. This harness has a honeycomb stitch pattern where I can easily count the shapes and see that nothing is broken. Continuing on to our hardware, you need to ensure that all buckles and attachment points are working properly. And look for dents, pitting, and corrosion, similar to what we were looking for on our back D-ring. It looks like everything passes on this harness, so I am okay to continue my work. Here's an example of a damaged harness. You can see off the bat that the webbing is torn, and there are several holes and burn marks throughout this unit. This harness should be taken out of service immediately. And now, back to Chris for letter C and the ABCs.
And now we're going to talk about the C of the ABCs, which is our connecting device. With this, we have two main options, the energy-absorbing lanyard and the self-retracting lifeline. So definitely the device that's been used for more time over the years is the energy-absorbing lanyard. So let's talk about that first. So as we've kind of alluded to previously, one end of this will attach to my harness, and the other end would go to the anchorage point. In a fall with a lanyard, there are basically two parts. So if we can imagine that this end is attached to my anchorage point and this end is attached to me, the first part of the fall is called free fall. That's where you're picking up speed until you get to the very end of the lanyard and this energy absorber starts to operate. So let's talk about what's going on when that happens. So inside that pack, we have what's called an energy absorber. In this particular case, it's what we refer to in the industry as tear tape. So if we can imagine, we've got rolled up material, and as I hit into it, this is my braking mechanism. So the tear tape actually rips right down the middle. We can see in this particular case that in this particular drop, we didn't go all the way through the energy absorber. Probably the biggest limitation with an energy absorbing lanyard is fall clearance. If we go to the charts, we'll just run through what some of the different letters would mean and put together exactly how much fall clearance we would need using a typical lanyard. So we can see that letter A is 6 feet. That represents the length of the lanyard. B is 4 feet. That is the tear out of the energy absorber or the tear tape that we talked about. We use 6 feet for the standard height of a typical worker, and then we typically add 3 feet of additional what's called safety margin at the bottom, basically just to give ourselves a little bit of extra room. As you can see, the total for all of those variables put together is 19 feet. What we need to do is compare that 19 feet that the system requires to how much is actually available. So if we look to the left and we measure from the ground up to the anchorage point and find that we have 20 feet available, the 19 feet that our system requires will not be a problem. On the other hand, if the feet available is less than the distance the system requires, that will be a problem. So the second option that we mentioned is what's referred to as a self-retracting lifeline. So actually, this small device goes by another name. This is actually part of a subset of self-retracting lifelines called personal fall limiters. This is called that because unlike the bigger devices, for example, what I have on this end of the table, this is designed to attach to the back of my harness. So again, operating characteristics. Let's go through a little bit how this thing works. So same concept. In this case, one end goes up to the anchorage point, the other end attaches to me. Once again, if I fall, what will happen is there's a line on the inside that's wound around a drum. As that line starts to come out very quickly, there's a braking mechanism that locks off. So I'll demonstrate. As you can see, if I compare that to what we did with the lanyard previously, I don't go nearly as far. Now, I can't show you the braking mechanism as well as I could show you with the lanyard, but I can tell you that inside of this, the drum will still spin, allowing a little more line to come out. However, the stopping distance will be drastically different. So again, if we look at the charts, we see the fall clearance chart for SRLs and PFLs. So once again, we have certain numbers that we're working with, but you'll notice that the numbers are fewer in this case. So the first letter that we're working with is A, and we can see that that is the maximum arrest distance that the SRL or the PFL will go in a fall. So in the case of what we call a Class B SRL under ANSI, the total stopping distance or the total arrest distance is 4.5 feet. And then once again, we have a safety margin of 3 feet. Add those together, and we can see that this particular system only requires 7.5 feet compared to the 19 that we saw with the lanyard. Once again, we have to compare the length of distance that this system requires to how much is available. The one big difference that we see with SRLs and PFLs is that here we measure from the ground or nearest obstruction to the work surface as opposed to the anchorage point. But once again, we can see we have a much smaller number in distance that this requires. So that would be a big reason that a lot of companies are switching from lanyards to SRLs and PFLs. Basically, you can use them a little bit closer to the ground than you could have with a lanyard. So one additional topic that we should talk about is misuse. And this, what I'll talk about here, applies not only to self-retracting lifelines, but also for PFLs. And one specific misuse that I'd really like to discuss is a situation where the person ties off below themselves and or possibly in a location where they could bend a line over an edge in a fall. So that's commonly referred to as a leading edge falls, with the edge being the leading edge. In the United States and in Canada, we have ANSI and we have CSA that have given us standards to designing equipment that are specifically designed for falls where the person is tied off below and possibly will go over an edge in their fall. So with these particular devices that are designed to these standards for leading edge, the only way that I know that I've got a product that is specifically designed for that is by reading the label. So on the table, I've got a leading edge PFL and a leading edge SRL. If I read the labels on each, they would tell me that they're designed specifically for those types of applications. The major point here is just knowing that you've got the right products for a particular application. And with that, I'm going to hand it back to Ann. She's going to get us started talking about rescue.
Now that we've concluded the ABCs, we can't forget about rescue. Even though we've made great efforts to prevent falls, we still have to make plans to rescue a fallen worker. OSHA says rescue must be prompt, so make sure you have something prepared and pre-planned. Suspension trauma is something that can result from sustained immobility. It can cause symptoms like dizziness, weakness, sweating, and venous pooling, which can reduce blood flow. So there are some options for product, assuming your fallen worker is conscious, that they can temporarily use while they wait for prompt rescue. Suspension trauma relief steps are an accessory that you can attach to your harness. They provide footholds that you can step into when you're suspended in a harness to relieve the pressure on your legs. But what if your worker is unconscious? What's an option for getting them down promptly and safely? Let's see what Chris has on the tower.
All right, thanks, Ann. So what we have here is a scenario where we have a fall victim who is suspended and unconscious, unable to help themselves. So for this type of a rescue, it could be very difficult if I don't have a special tool for getting them down. What I'll be using here is what's called the rescue utility system. Basically, it's a rope and pulley system that has what's called 4-to-1 mechanical advantage. The idea is I only feel 1/4 of the weight of the fall victim that I'm trying to raise. So if the victim weighs 200 pounds, I only feel 50. So with this, the first step that I need to take is to measure things out to make sure this is long enough to reach. Now, I'll take the carabiner on the ends, and I'm attaching into a special carabiner on the end of my pull into this little blue loop. And I have a carabiner that's held open by a pin on the end of the pull. So now carefully, I'll bring my pull out. And my goal here is to try to snag that D-ring on the back of the harness. Once I get it, I'll take the pull out of the way. Now, my next step is I'm going to put a handle on this rope to make it easier to maneuver. So I'll put that on one side of the rope and attach the other carabiner on the other end to myself. My main steps here are to raise the fall victim to the point where I can disconnect him from his fall arrest system and then lower him down. It's always a raise and a lower. So I'll start bringing the rope system up. So my goal is to take the tension off of his PFL. In this case, I've done that. So I'll disconnect, and now all full control is on the rescue utility system. I've also got a lot of control when lowering. So it only takes a few pounds of force to hold a very heavy victim. I've got control with the handle, but if I were to let go, it's kind of like my brake. So at this point, I'm going to go ahead and lower him down to Ann a little bit at a time. At that point, when he's on the ground, we can start first aid CPR, whatever's needed, and move him from there. But the main idea with this tool is just to show you the ease with which we can get somebody out of this position, and maybe also illustrate the difficulty that we would go through if we didn't have something like this.
As mentioned, there are many options for safe and prompt rescue. Hopefully you learned something new or got a refresher. And now let's move on to our Q&A.